So I told Jasnoor earlier today that I was going to be his hype beast tonight, and I am happy to be that right now. So if I had to describe Jasnoor as two words as an engineer, I'd say creative, absolutely creative, and intensely curious. My favorite memory working with him this summer was when we were working out some kind of regression, logarithmic regression, to turn his sensor data that he got from his flex sensor into an actual angle. And we took, initially I was going to say, let's take a nice 10, maybe 15 measurements. He wanted to take like 40, and we did. We took as many as we possibly could to get the data as good as possible. Then we did a simple logarithmic regression, and I thought, that looks great. It fits the log curve pretty well. And it's gonna, we'll be able to reverse that, put it into the code, it'll be super nice. And then he said, how do I make that more accurate? What do I add to this to make it better? I want my curve to fit more. And that's what we did. You'll see that. You see the graph right behind me, and he'll talk about it more. And I think that really just encapsulates how this whole summer went. Anytime that something was good enough, he strove to make it better. And I absolutely loved working with him, and I hope you all enjoy his projects.
I'm Jasnoor. I go to bases, and this is my risk rehabilitation device. And so it has a lot of different parts in it, and so you can see them here, so it's easier to see on my hand. So this is the flex sensor, and I'll explain how it works later, but it can basically measure the angle at how much it's bent. This is the ESP33, which is like the brain behind the whole thing. These are accelerometers, but only one of them is included in like the base project. And then there's just some wires and like resistors, different values of resistors, depending on how much each thing needed. And so I chose this project because I think many people these days use computers and have horrible wrist posture when using it and their mouses, and including myself when I play video games. And yeah, so as you can see, if I was to bend my wrist this way, this light would start going off. This light would start going okay. This light would start going. It obviously doesn't like me. If I bend it this way, this light starts going off and this vibrator starts buzzing to inform me that I'm bending my wrist bad this way. But since the accelerometers are on the side, it kind of like sometimes goes to other ones because it's like not even. As you can see, I'm very bad at sewing. And so yeah. So some of the modifications I added were this LED ring to help inform the user of where the issue is coming from, so they don't just have to figure out which vibrator it is that buzzing. But the vibrators I also added, since the original project had a buzzer, it was very loud. Yeah, and then so I added this arm sleeve. It was just this glove originally, but I added this arm sleeve so I could move some of the parts up, so it wouldn't be super clumped and make it really heavy on the wrist and just like weigh it down. And so, yeah, those were my modifications. And so my biggest challenges were being accurate with these accelerometers, because the original project only had one accelerometer, as I said, and so its movements an accelerometer detects its position based on its like degrees in this direction, and then this direction. And so if you only use one, moving your hand this way would be the same as moving it this way. But if you have two, you can find the difference in between that area. Like if I bend it like this, let's say that's like about 45 degrees, then you can find the difference between them to figure out the actual angle that the hand is bent at. And then so my next issue was measuring the flex sensor data, which as Mr. Ben talked about, I took a lot of measurements. There's a lot of data here. And so I fit it really tightly with those cosines and that regression that he was talking about, because I measured it very accurately at a lot of points. I was there for like 2 hours just measuring with a protractor. so like the x-axis is the value returned by the flex sensor. It's a pretty random number and it depends on the strength of the resistor you use. But so, for example, it would be if 400 here is like close to 0 on the y-axis, which would be the angle. So then I would make it so I would tell it that the angle is 0 if it's around 400 from the return node. And then the last issue I had was with this website. And so I made it so it sends the measurements of each of the different values for those degrees that I was talking about with the accelerometer for both of them. And it sends it every 12 seconds. And the biggest issue with it was I would send too much data, it would get mad at me and I would get banned for a few seconds. And so Bluestep has helped me a lot with learning about hardware since I usually only do stuff with software. And I think I've really grown a love for hardware because of it. And so I think my next steps would be to make a project like this but more advanced, maybe. Yeah, that's it.
Where is the flex sensor?
It's the one that measures the up and down, while these ones measure like the left and the right. I made it so you can like change the values yourself depending on like, because like different people might have like a different amount that they can do when they heard it, like a certain amount. But I think I had it set at like 35 for like left and right, and then like 50 or like 60 for up and down. Just like some general values.
How do you decide where to place the sensor interest?
So I decided to do it here and here for the accelerometers because it was I had to find the difference between them, and this is like where your wrist is, right? You know, like this part bends. So this part isn't going to move if you're actually bending it, and this part is going to move. So that's how I can find the angle, the difference between them. And this one's just on the back because it's pulled up and down and things like that. Yeah.
Where is table of measurements? How did you get the Y values?
The Y value, those were the ones that I measured
How did you measure?
with a protractor
Okay.
ruler, and it was like really tedious.
Did you have to use the calendar?
Oh, what?
The calendar?
It's built into these two. They're 9-axis IMU, so they have a gyrometer, they have an accelerometer, and they have a magnometer.
That's what's giving you the orientation and
Yeah, they're both in.
beyond.
So people know where you are developing against that. Some people, case are worried with baseball or basketball, so they kind of.
I mean, if I like probably like put the wires together maybe and like actually like get like a cover on top of it, because I might get like damaged, you know. But I think it's good work, yeah.
I was wondering, like, have you learned anything about your wrist posture? Like, has it caused any lifestyle improvements since you started, the way you were in the project?
No.
Did you have, like, was there like good resources online for your project at all, or
Like,
I guess like were you following a tutorial while you were?
no.
No, it was all like from.
The past project, so it was like, the past project was the one that only had one accelerometer. I actually have no clue how he did it, because he could have just moved his arm like this and it would detect it the same as moving it like this, because it's only one. So I have no clue how he did it, so I just didn't follow him after that.